This is the solution to WEX 300. Okay, so the first step is the natural domain. Well, the 8 is fine. There's nothing wrong with the 8. The 2 is fine, but this that fraction, that rational function, cannot be evaluated at -6, so it's anything but -6. But in principle, that inequality can be evaluated anywhere else. All right. So now, okay, the next step is the 0 and simplify step. So for this, we want to get one of the sides to be 0, so I'll move the 2 from the right side to the left side, so that we get x minus 5 over x plus 6, that part is unchanged, and then subtract 2 from both sides so that we have plus 6 greater than or equal to 0. So that's 0 now. So now I'm going to combine this into a single fraction. So this would be x minus 5 over x plus 6, and then plus, I'll multiply that by x plus 6 over x plus 6. Now they have the same denominator, so this could be written as x minus 5 plus 6, x plus 6 over x plus 6 greater than or equal to 0. So then I'll multiply that out. So then this would be x minus 5 plus 6x plus 36 over x plus 6. So that would be 7x's. And then plus 36 minus 5, so then that would be plus 31 over x plus 6 greater or equal to 0. Okay? So then 3. Now we want to solve the corresponding equation. Oops. So specifically, we want to consider 7x plus 31 over x plus 6. But now instead of an inequality, we're going to solve the equation. So now I'm going to multiply both sides by x plus 6 so that we get 7x plus 31 is 0, so that 7x is negative 31, so that x is negative 31 over 7. So negative 31 over 7. And just to help make sure I know about how big that is, so the calculator is telling me that that's about 4.4, negative 4.4. So it starts out as negative 4.42 ... Okay, I just needed to know where it was with respect to negative 6. All right. So now we'll make the sign chart. There's 2 fence posts to plot. Negative 6 is the one further to the left. Negative 31 over 7 is there. So In here I'll put negative 7. In here, since that's negative 4.42, I'll put negative 5 in here. And then in here, I'll put negative 4. Okay, so then now we want to plug that into this. So negative 7, so that'd be negative 49 plus 31, so that'd be something negative. Divide by something negative, so negative over negative. For this one, that'd be negative 35 plus 31, so that's negative over positive, so negative over positive. And plugging in negative 4, so that would be positive over positive. So the overall sign would be positive, negative, positive. Then we can now make a conclusion. So we want the positive regions. Now, the reason why we want the positive regions is because of this right there. So we're saying we want this ratio to be greater or equal to 0. So we want the regions that are labeled with positive and possibly the boundaries. So we can't have negative 6. Negative 6 is not okay because it's not part of the natural domain. So as for the boundaries, x equal to negative 6, no, because it's not part of the natural domain. And for the boundary x equal negative 31 over 7, yes. In the end, the reason why yes is because it says greater or equal. As a result, the answer to the question is we want to be to the left of that fence post and not that fence post. So it could be x is less than negative 6, or to the right of this post, this fence post, x greater than or equal to negative 31 over 7. As an interval, in interval notation, that's negative infinity to negative 6, union negative 31 over 7 to infinity, and as a plot, negative 6 and left of that is a piece, and there's another piece, negative 31 over 7, and to the right.